Okay, now today we're going to talk about graphing and inversing an exponential function. This is the generic equation that b is the base of what is growing or decaying, which is called the factor. So when we start off and we have a growth, we're going to define that b. We're going to do 1 plus that rate. And then what happens with that is the base becomes greater than 1. And then when I have a decay, we are subtracting 1 minus the rate. So then that base becomes less than 1. So it kind of helps you know if you have a growth or decay. The base can never be 1 because nothing's growing. 1 to any power stays 1, so it can't grow or decay. Okay, the a value in these equations is called the initial value, which is our starting point. The r is a rate, which is usually in a percent and that we convert to a decimal. Remember, 2 places. To the left from percent. And then the x is going to be the time that we're looking at. That is the x value. And then the output, the y, will tell us how much we get at that time. Okay, and then a quantity that grows or fixed by a fixed rate, that's a r, at irregular intervals is said to have exponential growth or decay. Okay, here we have it set up just so we get used to the vocabulary that we need to keep up with as we go through. I can look at that base. That base, remember, is what the x is raised to. So that base is greater than 1, so it is a growth. The initial value is what we start with, and that number is 0.07. The growth or decay factor is that b, which is the 3/2, but the rate, since it's a growth, is 1 plus r equals the 3/2. I subtract that 1 and I get 1/2. So the rate is 1/2, or we could say 50%, or we could say 0.5. They're all acceptable. Okay, so the next one that we're looking at is this is the base. It is less than 1, so that makes that a decay. The initial value is 4. The factor that we're growing or decaying is 1/4. And then this time, 1 minus the rate equals 1/4. I'm going to subtract the 1, so negative r equals negative 3/4. Divide by negative, and it's 3/4. So the rate is 3/4, or 75%, or 0.75. Okay, just some more practice with that. This is a good time to stop, fill it out, and see if you're right. So I'm looking at my base is 3. That is greater than 1, so that is a growth. The initial value is 2. The factor is 3. So my rate is rate plus 1 equals, or it's 1 plus rate equals 3. The rate is equal to 2, so that's 2, which is 200%, either one of those. Just remember, when it's a whole number, that's a percent, makes that over 100%. And then this next one, the base here is 0.04. Excuse me, that is less than 1, so that's a decay. The initial value is 1/2. The growth factor is 0.04. 1 minus the rate equals 0.4. Subtract that 1, so negative rate equals negative 0.6. Divide by negative 1, it's 0.6. So my rate is 0.6, or 60%. Okay, these are graphs of a growth and decay. The one on the left is a decay, because as I read the left to right, it is decreasing, it is going down in that direction. And then the next one is a growth, because when I look at that, reading it left to right, that is increasing. So that's how you can tell a growth and decay on the graph. Both of these will start at, we'll have an asymptote at y equals 0 until we transform them. So they have an asymptote here. And they also have a point that begins at 0, 1, or 1 above that asymptote. That is normal. Now notice the numbers over here are the negative x's, and the numbers here are positive x's. That means as I go to the left, I'm using negative, and as I go to the right, I'm using positive. And this has the same pattern because it's 1/2 and 2. So they have a very similar pattern, but when I'm a decay, I'm going to go left, and when I'm a growth, I'm going to go right. Because here, if I look at my whole numbers, 2 to the negative, 1/2 to the negative 1, because that's what we're doing. It's 1/2 to the x. So my x's are going to be at 0. When x is 0, it's 1, because anything to the 0 power is 1. And now with the decay, I go negative 1, because 1/2 to the negative 1 is the reciprocal of 2. And then 1/2 to the negative 2 is the reciprocal, which is 4. So over 2 up 4. And then the reciprocal of 1/2 to the negative 3 is positive 8. So that one's there. And so that's that pattern of 1, 2, 4, 8. That same pattern occurs when I do 2 to the x, except now I'm going to go to the right. I'm going to go 0, which is the 1, which is where I start. 2 to the first is 2. 2 to the second is 4. And 2 to the third is 8. So I just think if I have a decay, I'm going to go left. If I have a growth, I'm going to go right. And that is the pattern. Now we're going to discuss the end behavior. As x goes to the left, so we're thinking about as I go to the left, y is going up. So that's easy to see. But, let me change my pen. But as I go to the left, y is hitting that asymptote, and that's why we use that asymptote. The same thing occurs here. As x goes to the left, my y is going to the asymptote. So this would be as x approaches negative infinity, y approaches the asymptote. And then as x goes to the right, y is going up. So as x approaches infinity, y is going to infinity. Okay, we're back at the transformations. My shift up and my shift down is coming from the k value. Notice that I have +2 and -3. Okay, so we got to keep that in mind. Now, when I shift left and shift right, notice that it's up here in the exponent, and that's my left and right. And then reflect over x is my a value. And we're not going to really stretch these. We may talk about it while we're graphing, but I want you to just to know the basic behavior of reflecting over x. I did leave out on here, and I need to write it in, is reflect over y. So this would be, wrong pen. This would be f of x equals, say 2. It would be negative x plus, let me not do a plus anything, negative x. So what that does is that's a reflection over the y because of where it's located. So that would be your b value. Okay, so now we're going to graph. And the thing to remember is we're going to transform the x and y axis because this all starts at the horizontal asymptote at 0 on the x-axis. So we're going to kind of have a starting point there. So this first one is just down 3. So that means I have a horizontal asymptote at y equals negative 3. So the equation of the horizontal asymptote is y equals negative 3. Nothing else changes. So this right here is where I've transformed that beginning 0, 0. So this is a growth. So I'm going to take the pattern and I'm going to go to the right. So this is 2 to the x, and I'm going to do 0, 1, 2, 3, and then 2 to the 0 power is 1. There's that 0, 1, 2 to the first, 2 to the second, 2 to the third. So here I'm going to go 0, 1. That's what it always does, is 1 above the asymptote. And since it's a growth, I'm going to go right 1, up 2, go back to that 0, 0, go right 2, up 4, go back to that 0, 0, go right 3, up 8. This hovers on top of the asymptote, hits that pivot point, and grows. Okay, this next one, let me finish my domain and my range. This graph from left to right is negative infinity to infinity. And then my range is bottom to top. So at that asymptote at negative 3, up to the top at infinity. As x goes to the left, my y is going to the asymptote at negative 3. As x goes to the right, it's going to positive infinity. Okay, so now this next one, I'm shifting it up 1. So there's my horizontal asymptote at positive 1. So y equals 1 is the equation. I have no other shift, so I'm going to do 1/2 to the x, which starts at 0, 1. Now because it's a decay, I'm going to the left with my numbers. So 1/2 to the negative 1 is 2, and that's 4, and that's 8. Notice that the pattern is exactly the same, so you don't need to worry about remembering those numbers. I am using 2s, 3s will change it. So now when I go and graph this, I go 0, 1. Remember, this is where I've shifted everything. Hang on. Sorry about that, got a phone call. So we know that we only shifted it up, so that's my starting point, so I don't have to, that's where I'm going to start counting everything from. So I'm going to go 0, 1. Now I'm going to the left because I'm a decay, so left 1, up 2, back to 0, 0, left 2, up 4, back to 0, 0, left 3, up 8. This time it starts up big, hits that pivot point, and hovers above the asymptote. Okay, so my domain is negative infinity to infinity. My range is bottom to top, so that's going to be 1 to infinity. As x goes to the left, y is going up, so it's at positive infinity. As x goes to the right, it's hitting that asymptote, which is at 1. Okay, I've got 1, now I've got 2 transformations. So my asymptote's at positive 2. So that equation is y equals 2. Then I am going to the right one. So that green dot is where I'm going to start graphing everything from. So I have a growth, so we're doing 2 to the x. Since it's a growth, I'm going to go in the positive direction to the right. And 2 to the 0, 2 to the first, 2 to the second, 2 to the third. And so from that new point, this is my 0, 1. Because remember that green dot's like 0, 0. So I'm going to go to the right one, up 2. Back to 0, 0, to the right 2, up 4. Back to 0, 0, to the right 3, up 8. Hover on the asymptote, and up we go. My domain is negative infinity to infinity, and my range is from the asymptote at 2 to infinity. My end behavior, as I go to the left, I'm hitting that asymptote because I'm going down to towards that asymptote. So that is going to approach 2. As x goes to the right, it's going up to infinity. Okay, so this next one, I have a horizontal asymptote at -3. I have shifted to the left 2. So there's my shift of my 0, 0. The equation of my asymptote is y equals -3. This time I'm powering the 1/2 to the x. So I'm going to go left. And the same pattern, which is 1, 2, 4, 8. So 0, 1. Go back to that green dot, 0, 0. Go over 1, up 2. Back to 0, 0, over 2, up 4. Back to 0, 0, over 3, up 8. I start at those points, hit that pivot point, and hover above the asymptote. So my domain is still -infinity to infinity. My range is the asymptote up to infinity. As I go to the left, I'm going to positive infinity. As I go to the right, I'm going towards the asymptote, which is at -3. Okay, so I've got 3 transformations. I've got a reflect over x, a left, and an up. So I'm going to go up with my asymptote to 4. And the equation of the asymptote is y equals 4. I am going to shift it to the left 2. So there's my 0, 0. So I'm first going to go put on my pattern that we've learned. I'm doing that 2 to the x. So that's going to be 0, 1, and 2, and 4, and 8, because I'm going to the right. But now I'm reflecting over the x, so that means I'm going to change my y's to the negative. So this time, when I graph this, I go 0, down 1, go over 1, down 2, back to 0, 0, over 2, down 4, back to 0, 0, over 3, down 8. Now I'm below the asymptote, and there's my graph. My domain is -infinity to infinity. My range is bottom to top, so that's -infinity up to the asymptote this time. As x goes to the left, y is approaching the 4. And we're going up to the 4. That doesn't really matter. And as y goes to infinity, we're going down to -infinity. Okay, so this next one, I have a decay. I reflect over the x, and I have a horizontal asymptote at 3. I'm shifting to the right 1. So I'm going to use my 1/2 to the x. Remember decay, I'm going to the negative. And so the same pattern, which is 1, 2, 4, 8. I'm reflecting over x, so these are all negative. So now, oh, I didn't put my asymptote. The equation of my asymptote is y equals 3. So now let's graph it. I'm going to go 0, 1. See, that doesn't change. Now left 1, down 2. Left 2, down 4. Left 3, down 8. So now this time it's going from this direction. So my domain is still -infinity to infinity. My range is bottom to top, so -infinity up to the asymptote. As x goes to -infinity, which is to the left, I'm going to -infinity. As x is going to infinity, I'm going up to the asymptote, which is 3. Okay, now we're going to do inverses, which remember switch x and y. I have already gone and I've written the equation, or written the points from number 7, because we're inversing number 7. Okay, so I've already put the points in, so I already know from the equation up above me, it's y equals 2 is my vertical asymptote, and here are points from the original. Remember, everything x switches to y, and everything y switches to x. So since it's y equals 2, I now have x equals 2. So there's a vertical asymptote because it's x equals 2. Now I'm going to switch my points. All I do, remember, is switch them. So the point 1, 3 becomes 3, 1. 2, 4 becomes 4, 2. 3, 6 becomes 6, 3. And 4, 10 becomes 10, 4. So I count over 3, 1. And then 4, 2. And then 6, 3. And then 10, 4. So I'm going to come up the asymptote and turn. And that is what the inverse looks like. Now we're going to do the next one. Again, I already have the points written in. My asymptote here is y equals 3, so now I'm going to have x equals 3. All we do is whatever is x becomes y, whatever is y is x. Now let's inverse the points. 1, 2 becomes 2, 1. 0, 1 becomes 1, 0. Negative 1 is negative 1, negative 1. And then negative 2, negative 5 becomes negative 5, negative 2. So now I go 2, 1. And then 1, 0. And then negative 1, negative 1. And then negative 5, negative 2. So this time I'm up here and turn. What this is a graph of is what a log looks like. A logarithmic function looks like this because the inverse of an exponent is a log. Okay, now we're just going to do a couple of word problems that we're going to write in that, oops, sorry, wrong pen. A to the B to the X, where B is either 1 plus the rate or B is 1 minus the rate. The A, remember, is the initial value. So now where I go through and the house costs this, ooh, wrong pen again, goodness. Costs $200,000, and the word appreciate means that it's growing, so it's an addition problem. And it gives me the rate of 3%. So now I have enough information to write a function that models the cost of the house over time. You can write f of x, but cost of the house over time is what we're comparing. And my starting value is 200,000. 1 plus 0.03 to the t. That's the function that models. Now we're going to use this model at 10 years. So 200,000, 1.03 to the 10. I just put this in my calculator and it will give me 268,783.275. This is money, so I know I'm going to round it to the hundredths. So $268,783.28 is the answer. Okay, here's another one. You have a bad cough and you attend your little sister's choir concert. You take 100 milligrams of cough medicine. Every hour, the amount of medicine is cut in half. Write a function that represents medicine in your body over time. So medicine in my body over time, I start off with that 100 milligrams, 1 minus a half to the t. Okay. It is safe to take more medicine when you have less than 400 or 4 milligrams. How long do you take some more? So I am going to solve this equation and see what I get. I am going to take that 100. I'm going to go ahead and do 1 minus a half as a half, or 0.5, and I'm going to do it to the 1. And when I do that, I get 50. Of course, half of it. That makes sense. 100, 1/2 to the 2. Cuts that in half, and I get 25. 100 to the half to the 3. That's 12.5. 100 to the 1/2 to the 4th, that is 6.25. 100 to the 1/2 to the 5th is 3.125. So it took me 5 tries to get there. So my answer is 5 hours. Now this is what we're going to learn to solve.